So we're back to videoing for everything once again. So hopefully you guys had a good break and did everything that you needed to do before the break actually happened, okay? Now for some of you, this is probably a surprise, even though I warned you multiple times during the previous week that we were here, that you needed to do some of that stuff on your own. Whenever we're out and we're online for an extended period of time, we still have material to cover. So there were videos and assignments that you needed to do as well. Here's where we're at today, 3-3, okay? 3-2 is due today. 3-3 is due tomorrow, okay? Because it's really, I think you'll find that for these particular lessons, it's actually going to be pretty easy for your mind to grasp, and the assignments are going to seem a lot shorter. Does that make sense? But I still need you guys to pay attention carefully to the questions and answer everything that needs to be answered. It's very frustrating for me when I see something and, you know, I don't get a complete answer, or the answer doesn't even make sense for what we have. Or people only do like half an assignment, first half or second half. It's just kind of random. You guys hurt yourselves by not doing the full thing. I'm always here to answer questions. But no questions, you get no answers, you ignore it, the grades suffer. Okay? So we're looking at slopes of lines today, but we're going to start off with a bit of review, or should be review, from lesson, this is going to work. There we go. Okay. So here's where we're at. 3-2 was a lot of stuff where we are looking at different angles that are formed by parallel lines. And because we have angles formed by parallel lines, we can actually tell certain things about them as far as whether they are the same size, i.e. that they are congruent, or if they're supplementary to each other, so that we can determine what these sizes are. So here it says that angle 4, which is this one right here, has a measure of 146. That's 146 degrees. They want us to find the measure of angle 2. Do I know what it is?
Yes.
What is it, Nathan?
146.
146, why?
Because they're both basically like they're not the same angle as in they're on the same like line, but
They are congruent?
They're congruent, yeah.
Yeah, okay. There are postulates, and if you'll look in 3-2, you have a corresponding angle postulate, a parallel line, and angle pairs. There's like 3 theorems, 3-1, 3-2, 3-3, regarding alternate interior angles, consecutive interior angles, alternate exterior angles. Okay? So 1 postulate, 3 theorems, and then there's a 4th theorem, the perpendicular transversal theorem. Okay? If this is not ringing a bell, you need to look that up as soon as possible. We have another test this Thursday. Okay, that's going to be over 3-1, 3-2, 3-3. Okay, so Nathan says this. I tend to agree with him because what we have are corresponding angles. They're on the same side of this transversal. Okay, this is the transversal of these 2 parallel lines. That means that they're congruent. Okay? So angle 4 is still 146. Can I find the measure of angle 7? So instead of looking for 2, this time we're looking for 7.
Yeah, you can.
So what do I do this time? What do I know about this?
They're both
Well, if we know that this is 146,
Yeah,
we know that this previously was 146.
So 7 is acute. So it's
7
either
is
34
acute.
or 24.
34 or 24, where did those numbers come from?
Because
Yeah,
they're
it's in
They what?
yeah, it's in multiple choice.
Oh, okay, so we're ruling out those, we know it's acute. So is there a way to figure that out then?
180 minus 146.
So this here is 180 minus 146, which is 34. Okay? They are supplementary to one another. Doesn't this actually feel a little easy?
Yeah.
Yeah, hopefully. Okay? Find the measure of angle 10. So starting from the same thing, we already know this is 146, this is 146. This one was really 34.
That should be.
Do I know 10?
Yeah.
That should be 144.
Should be 146?
Yeah.
I would agree. Any idea why?
Cause it follows like the same pattern as the other one. I like the 4.
Yeah, it does follow the 2 and the 4. So I could go, well, this is a corresponding angle, so it's the same as 2. I could also say, well, vertical angles, right? Vertical angles could also help. But I would agree that this is 146. Okay, how about angle 11? Angle 11 is this one right here,
34.
Yeah. 34.
34.
Yeah.
Yes.
I admit, this is actually the part of geometry that I really like. Like, I can remember back to doing this in high school going, wow, this is like super easy. Remembering all the theorems and postulates, not so much. I looked that stuff up. Okay, as far as why it is the way that it is. But these angle relationships are kind of fun because you're like, oh yeah, there's the pattern. Found that right there. Find the measure of angle 11 plus angle 6. If I were to add up 11 and 6, let's see if that'll help a little bit. We said that angle 11 was 34, right?
Yeah.
If this is 34, do I know what 6 is?
Well,
There's
yes.
a few different ways to figure that one out.
Yeah, 6 is 146.
This one's 146, so the total is
180.
180. Okay, we have 5th Street and 7th Street. That's these two lines are parallel. We use this symbol to indicate that they're parallel, just like, you know, when we had a triangle before and we said, oh, this is the same as this, and we said those are congruent, the same size. This means congruent, these mean parallel. Okay, so those two are parallel. At what acute angle do these two streets, that's this one and this one. So we want to know where they meet. What is the size of that angle? Do we have a way of determining? I don't know how much of this is your brains trying to warm up, how much of this is, hey, I never looked at 3-2 and I need to do so like today because I know it's due tonight. Because you were given last, I think Thursday, Friday, meaning the week before. This angle and this angle are congruent. They're alternate interior angles. So that means that's 75. If that's 75 and that's 53, can I determine this? I can. Add these together and subtract that from the 180. And I'm left with 52. If you're lost, you need to take a serious look at tree 2. Okay, so what we're doing today is we're looking at tree 3. We looked at parallel lines to determine different types of congruent angles and supplementary angles. Now we're going to use these things to find the slopes of lines. And use the slope to identify whether something is perpendicular or parallel. Oops, let me go back. Nope, wrong way. There we go. What's a slope? Does anyone know what slope is from science class and algebra from before? No one knows. No one cares.
I know what it is, I just don't know the exact definition.
Well, give me what you have.
Okay, I can read the exact definition.
No. I don't want an exact definition. I want to know what's in your brain right now. When you think slope, what do you think?
Lines.
Lines, like. So, like, this means slope to you?
No, like the line.
No, as in like going up and down.
You think
I think
horizontal.
you think of these two as kind of the same thing, like a slope is a rate of change?
Kind
Okay.
Yeah.
We could have lines like this. We could
Yeah.
have a line like this.
Yeah.
They all have different slopes. Slopes means how much has something changed. Okay? We're used to seeing it, hopefully, where we go like, hey, this is the y-axis, this is the x-axis, and we plot a bunch of points, and we have to put a line through, and we go, okay, well, how did that change over time? Because quite often, this is time, and then this is something else that we're measuring. Sound about right? Okay? So a slope, and when I hear a slope, immediately, my brain says, rise over run. Have you ever heard that before?
Yes.
Rise over run. That will tell me how fast I am rising as compared to how far I'm running. Okay? Change in y over change in x. My brain does weird connections to try to remember things and make sense of things. And I try to pass these weirdness, on to you guys because it's a lot more fun than just reading the textbook. Sometimes. Okay? So we have this rate of change. We're looking to see how long it takes to change it by a certain amount. So here is the exact definition. In the coordinate plane, the slope is a ratio of change along the y to the change along the x between any 2 points. And depending on the line, like if we don't have a straight line, if we have something that curves or something that changes, which 2 points we pick can be important. But in this case, all that we have is like one basic line. Okay? Now you notice that they use this symbol, m. That lowercase m stands for slope. Okay? This is something that sticks with me from now until the end of time. And you're like, well, what is that? Have you seen this before? Yeah? What can you tell me about it, Trina?
Honestly, all I remember is that song that Miss Cotter used to play.
Okay.
So it was like MX plus B.
Okay. So kind of like the YMCA song, but it's MX plus B. So what does this show us?
Y is like, Y should be like, I'm pretty sure Y is this, no, M is the slope, and then,
Okay, so M is slope.
and then the X, isn't that like the first point? Or it's like,
So this is, so I can basically say, hey, I have a point. Maybe we should call it a point coordinate.
yeah.
And this one here is also a point coordinate. Now, like, I'm honestly not expecting you guys to like memorize and know all this stuff. I'm just trying to see what's in your brain. Since I can't physically enter your brain to figure it out, I have to ask these questions.
And the B is the actual like rise over around.
No. I'll give you a hint. This here is the B.
Probably the Y.
Starting.
No,
Kind of.
B is like your it like it's serves as both the starting point and your like rate of change.
Not sure if I describe it quite like that. Like when I label it like this, it looks like I'm describing this as a point, and it is and it isn't, because all we're doing is we're only concerned about the value of what y is as it crosses. Okay, so this is something known as a y-intercept. The y-intercept is where does the line intersect? Where does it cross? Where does it intersect as it goes through the y-axis? And so all we have to be concerned about is what is y, not what is x. Okay? So in this particular one, if I were to look at this, I'd have to calculate what the m is. And I could calculate by counting what the b is by just seeing what y value. And as soon as I have this and this, and I put it into this equation, I've described that line. That I can find any points along that line using this equation. Okay? So this is not necessarily something new. This is just something that's, hidden away in your memory bank somewhere. Whether it's attached to a song, a good memory of a good teacher. But it's there, and honestly, even though it was from a different class, it applies. The things you learn in science apply. The things you learn in algebra apply. The things we learn in English, believe it or not, apply. Okay? So, here's how I calculate this rise over run. I need to look at the change in y, which means I need to look at y2 minus y1, and my run x2, which is up here, and x2, x1, and it gives me a slope value. Does it have to be a whole number? No, doesn't have to be a whole number. Does it have to be positive?
No, it doesn't have to.
It doesn't have to be positive. Okay?
The slope could be going down.
If it's like this, I have a positive slope. If it's going like this, I have a negative slope. What happens if it's this?
It's
No
slope. Like neutral.
No slope. M equals 0. What happens if I have this?
you just have the y
Your
intersection.
calculator screams in terror because it will literally tell you error or undefined.
So that can just be considered a slope or
No, it's considered error. Like, here I can use this in a calculation. This is, can't do it. Okay? So horizontal line, slope is 0. Vertical line, you end up with an error or undefined. It's just the way it is. So let's find the slopes of these lines. Hard work, I know. Hard work. So what is the equation? M is equal to rise over run, which is y2, y1 over x2 minus x1. I need to be able to count squares on a graph. Okay? You can see right here that this is 0, 0. That's the origin. Now I need to take any 2 points on that line. Do I want to use this point right here? Not really, because it's not at, any clearly defined point on the graph. So let's pick 2 that do look like they're crossing at good locations. I do like this one. And I think I'm rather fond of this one. These I think are my best options, because they're where different x and y meet. Okay? So this is my 2, this is my point 2, this is my point 1. So y2 is positive 3. My y1 is positive 7. Would you agree? They're like, I'm having trouble counting. My x2 is negative 2, and my x1 is negative 3. Right? This is negative for x, this is positive for x. This is negative for y, this is positive for y, when this is the origin. So 3 subtract 7, negative 4. Negative 2 subtract 3, negative 5. So we end up with 4/5. Did I do something wrong? I feel like I have. Y2. Oh, that's where we are. Y2 subtract Y1. X2 subtract X1. No one corrected me. Negative 4, negative 2, subtract negative, so that's like adding. That looks a whole lot better. So I'm left with, our slope is negative 4. Meaning it's going downwards for every 1 in this direction, I'm going down by 4. Okay, and so that's what they show us. We use the slope formula. We plug stuff in. They chose some different points. they chose what they did. So they chose here for x1 -3 plus 7, which is this. And they used -1, 1. They actually used this. I would say that ours is more accurate than theirs.
If they use that, point T.
Oh, you're right. You're right. Now, then what was our answer that we got? -4. Okay, they chose down here rather than where we did, but it still ends up with the same answer. They just chose a point that was over 2 and down by 8. Regardless, you need to pick ones on the same line. Okay, find the slope of this line. Where do you begin? Here's our origin. Okay, we have -2, -5. We have 6, +2. We put that into the equation. Substitute in the numbers. And you're left with 7/8. So for 7 increase this way, we're going to go up by 8. Okay? Find the slope of this line. What's the slope of this one? Error. Why?
It's going like
I can't divide by 0. There's no change in x. Slope is undefined. So as soon as I see something that's horizontal, I go, oh, m is 0. If I see vertical, m is undefined. What's the slope of this line?
No slope.
No slope, it has 0. Slope is 0. Why? Because we have 0 divided by some number, which is still 0. Okay. Who can find the slope of this one?
So how can you remember like which slope is like negative and positive? Like which way it's pointing?
Well, honestly, I just remember that if it's this way,
Yeah.
it's positive. If it's this way, it's negative. But you also got to look at it this way where no matter what, you're always doing this y2, y1, x2, x1. And if you end up with a negative slope, like you'll know directly from the numbers. Anyone got an answer for me?
Well, B and D are definitely out of the question.
I'm hearing B and D are definitely out. Why?
Because
Positive.
Because they're positive and this ain't positive. So is it 5/3 or 3/5? Well, look at the amount of change. Okay? Change in y over change in x. So does y change by 5 or does it change by 3?
Changes by
We're going from here to here. I see an increase by 3 squares. And I see a change here by 5 squares. Change of 3 squares y. Change in 5 squares x. I know it needs to be negative. I'm expecting C. And that's what we get. Okay, find the slope of this one. Nice and easy.
0.
Defined.
0. This one is defined because I have 0 change in y, but I do have a change in x. 0 divided by any number is still 0. How about this one? See, this is really difficult homework for tomorrow, right?
It's gonna be positive.
It's going to be positive.
I'm gonna just say.
So we're already going, nope, nope.
I'm going for D.
You're going for D?
Yeah.
Because there's no way that rise is 1 block and 2 to.
Yeah.
There's no way.
I will agree with you.
Yeah.
And sometimes you don't have to do the whole calculation unless they ask you. If they tell you, hey, you know, calculate this, show me your answer, like, then I have to. But if it's just find the slope, and I have choices A, B, C, D, make life easy for you. Slope,
Undefined.
undefined, can't divide by 0. So positive, negative, 0, undefined. And I guess to some extent you have to think, hey, I'm starting from the origin. If I have to go up, that's positive. If I'm going to be going downhill, that's negative. That might be a way to remember that too, as far as the positive and the negative. I think the 0 and the undefined are pretty easy to remember. 0 slope, hey, that's just walking on the sidewalk. And you know, if you had to make a climb like this, nope, 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 nope. I'm not in for like wall climbing. Okay, so here is using the slope as a rate of change. Okay, the annual sales for one manufacturer of camping equipment was 48.9 million. So that's in the year 2000. I have these sales. In this year, I have these sales. And I need to know what is going to be my sales in 2015 if it follows with this same rate of change. How do I determine that? What would you do?
Put it like a little graph.
Okay, I could try to make a graph of it, definitely.
Or I mean, you could subtract 85.9 by 48.9, and then add.
If I start doing something like this,
Yeah.
and I say, okay, well, this is 2000, this is 2005, this is 2015, and I know, now this is not going to be exact, this is just giving myself a rough sketch so I can keep track of what this looks like in general. Okay, so I have this line, and I'm extrapolating to work out, well, what is this here? Does that help us? It does for me because I have a nice little picture.
I wish I made the table.
Okay. Another thing that we can do is let's look at this rise over run. Like, I can figure out the slope of this line from here to here by plugging in this information. Right? So if I plug in that information, y2, y1, x2, x1. What is 85 subtract 48? $37 divided by 5, that's my slope.
Can we simplify it? Or?
You could. In this case, I could also say that that is 5, I'm sorry, 7 2/5 Or I could also say that this is 7.4. Now, what do I do with that information?
Why is it?
Well, let's see what they do. So first off, they gave themselves a little graph. Okay. So they did a graph very similar to us. And drew that line through them. Then they found the slope of the line, 7.4. So we're increasing $7.4 million per year.
That's what
So how many years are there between 2005 and 2015?
10.
So my sales were this. And I will increase by 7.4 million each year for 10 years. Okay? So what they do is they plug this back in. They say, hey, we know the slope. And we can use one of the points. And using that point, I can figure out my new y value. Okay? We're saying we know this, we know this, we know this. Actually, really, we know this one. We can figure out the new y too. Could I still just do it this way? I could. So they're using the initial value because that 0 for 2000 is awfully nice. Okay? So they put in the slope. This is coming from 2015 minus 2000, or they're just taking the 2-digit year. This is the initial sales value for 2000, and I can solve now for this. So what did they do? They did 15 subtract 0. Then they multiplied 7.4 by 15. Now they're going to add 48.9. So that my total sales now is going to be 159.9. I could also take this value and increase by 7.4 for 10 years. And I'm going to end up with the same. I could say 85.9 plus 10 times 7.4, and I'm still going to end up with 159.9. There's more than one way to do the problem. Either which way, we're making use of knowing the slope in order to determine something in the future. Okay, the sales in 2015 will be about 159.9 million.
For camping supplies? For camping supplies?
For camping supplies.
That's a lot.
You know, if you have a company like REI or, oops. They're like, woohoo, there's an answer. So we can do this the same way for this one. Okay, between 1994 and 2000, we have an increase of 14.2 million per year. So M is equal to 14.2 million per year. In 2000, the total subscribers, so that's really our X2, is 109.5 million. If the number of subscribers increases at the same rate, I guess really this is an X1. X2 is equal to what? We know that, oh, actually I have that wrong, sorry guys. You wanna know how I figured that one out? My slope is million per year. Okay, this is rise over run. Rise refers to Y, run refers to X. So if I have million, this is a Y. And we need to know what the new Y is. And we have a change in years to 2010. Okay, that's the bottom one. X2 is 2010. Okay, so I start plugging this back in. M is Y2 minus Y1 over X2 minus X1. What's my Y, what's my M? 14.2 million. My Y2 is what we're trying to figure out. My Y1, 109.5. Okay. We need to know over 10 years so all we now need to do is solve for this. Multiply by 10, multiply by 10. Add. And what did we get? What is 142 plus 109.5? So we're thinking 251.5. Have I lost you guys? Or is this just too easy? Kind of. It feels a lot easier than the things we've done in the past. Way easier. Okay, so determining whether something is parallel or perpendicular. So if we have non-vertical lines, because why does it have to be non-vertical? Because if I have vertical lines, M equals undefined, right? So they need to be non-vertical. They will have the same slope, only if they're parallel. Makes sense to me, right? These two have the same slope, so they're parallel. They're always going to be the same distance apart. Okay? Perpendicular lines, their slopes are inverse of one another. Okay? That the product of their slopes, is always going to be -1. So all we're looking for is, hey, do they have the exact same slope? Then they're parallel. If if I take the product of their slopes, because they're different, and I multiply them and I get -1, then I know that they're perpendicular. And so that's what we have here. These are parallel, these are perpendicular, and therefore these are perpendicular. If one of the parallel lines is perpendicular to the transversal, so is the other. So, they tell us to determine whether these are parallel, perpendicular, or neither. And then graph it to verify. Okay, so we need to figure out the slope for FG, and we need to figure out the slope for HJ. Okay, and either which way, slope is rise over run. So, first one, FG, -1 subtract -3. -2 subtract 1. Okay, HJ, 3 subtract 0, and 6 subtract 5. What is -1 subtract -3? That's -1 plus 3, so that's going to be 2. -2 subtract 1. So -2/3. 3 subtract 0. 6 subtract 5. What do you think? Do they look like they're parallel? They don't to me. Remember that if it's parallel, they're going to have the same slope. If it's perpendicular, then and if it's neither one of those, it's neither. Okay. Get 3-2 done today. If you have questions, let me know. This stuff is due for tomorrow. So you got like tomorrow night to do it too.